Hi my dear students, in the previous videos I discussed some questions how to find the value of x, clear, and also we discussed how to find the determinant value of the order 1, of the order 2, of the order 3, clear. And today's class I am going to discuss the properties of determinants. So my dear students, these properties are very important because in future I am going to solve the questions by using these properties. So these properties very helpful to solve some questions, and that such type of questions they will ask for 4 marks in your annual examinations. So properly if we understand the properties, then we can solve such type of questions easily, clear. So therefore now I'll solve the or I'll discuss the first property. So the first property is, my dear students, the value of the determinant remains unchanged if its rows and columns are interchanged, clear. So I'll first discuss the meaning of this statement. Whatever I wrote here, what is the meaning? It's that I am going to discuss. Clear. So the meaning is, my dear students, the value of the determinant. So if I consider any one determinant, so let us consider. I'll consider one general matrix I am going to discuss. So here it is. You can take it as proof. Let the determinant, this is the determinant symbol that already we discussed. So I am taking, I am considering one determinant. So generally I am taking it as a11, a12, a13, a21, a22, a23, a31, a32, a33. Clear. So I consider the one determinant, clear, of the order 3 cross 3. And now, my students, the value of the determinant remains unchanged if its rows and columns are interchanged. So this is the one determinant I have. So another one determinant I am taking here is, that is here delta 1. I'll consider another determinant delta 1, and here what I'll do, so this is whatever the rows are there, that I am taking it as column wise. So this is the first row I am taking it as first column, second row I am taking it as second column, third row I am taking it as third column. What I am doing here is I am interchanging rows into column. If you interchange rows into column, what happens? A11, first row I am writing it as column, A11, A12, A13, clear. And next second row, A21, A22, A23. Second row I am writing it as second column. Next A31, A32, A33. So what is the meaning means here? This is the one determinant I consider delta, and another one taking here this as delta 1. Difference to this and this determinant is, whatever I considered here delta, this determinant, whatever elements are there, these rows I write in terms of the columns. I interchanged the rows into columns. Now what they saying, the value of the determinant remains unchanged if its rows and columns are interchanged. It means if you calculate the determinant value of this, whatever answer you are getting, the same answer you will get if you interchange the rows into column. It means if you solve this one, the answer will be, whatever answer you are getting, the same answer you will get if you solve this also. So that is nothing but, if for any matrix, any determinant, if I interchanged rows into column wise, then also the value of the answer won't change. Answer will remain as it is. So that is the meaning of the first property. I hope you understood. Now I'll verify that whether the given statement is correct or not. Now I'll verify. And please remember, this verification, sometimes they may ask you in your examinations, in your annual examinations, for 2 marks or for 4 marks. They may ask sometimes. Generally they won't ask, but Sometimes they may ask. Clear? So for that purpose I am solving the proof for this. Clear? So what is that? First I will consider, let us consider delta. Now I will solve this determinant value. And already I discussed if the determinant is of the order 3, how to find the determinant value. That I discussed in the previous videos. The same procedure I am following here. So therefore for that, first consider here delta is equals to, I am now solving my distance for the row wise. So clear? So solving by row wise. Solving by first row. So if I wanted to solve the first row means I will write the plus minus plus. First I will write like this. After writing this a11, so here it is. First write the element a11. This is plus of a11. Determinant of what we are simplifying. What we are doing? We are converting the 3 cross 3 matrix in terms of 2 cross 2. That is how. So we can solving for by the row 1. So row 1 I am solving. So therefore, if I wanted to solve by row 1 means I will consider the first element of the first element. To that I will multiply with the deleting the where the a11 element is lies. So this row and this column I will delete, and I will take the determinant of the remaining elements. That is a22, a23, a32, a33. Next, minus of this element. So minus of a12, and again here it is this row and this column I will delete, and I will take the determinant of remaining elements a21, a23, a31, a33. I hope you understood. If you have any confusions in that, please see my previous videos. In that I discussed. Clear? And next, plus of this a13. Again this element, this row and this column. First row and third column I am deleting, and I will take the determinant of remaining elements a21, a22, a31, a32. Clear? So now solve this one, my dear students. If you further simplify this, I am converting the determinant of the order 3 cross 3 in terms of 2 cross 2, because we know how to calculate the determinant of the order 2. Clear? So therefore, and now further if you simplify this is equals to delta is equals to a11 into, I am solving this. So how to solve this determinant of the order 2? This element into this element minus of this element into this element. So therefore a22 into a33 minus of this element into this element a32 a23. Next, my students, minus a12 as it is, again this element into this element, that is a21 a33 minus of this element into this element a21 into a33 minus of this element into this element a31 a23. Clear? And next, plus of, here it is, I am writing here, so I don't have space here, so therefore this remaining I am writing here it is a13 is equals to into a21 a32 minus of, again here it is a31 a22. Further simplify this. So if I simplify means I will get here So further, if I simplify means I am getting here delta is equals to here, or else leave this much. So I am taking here this and this I will call it as 1, equation 1, or this value I will take it as 1. Clear? So consider this much value. So further you can, if you want, you can simplify, or you can write this much. And next, my additions, next what I will do, I will consider the delta 1. So delta 1 is nothing but, what is the delta 1? Delta 1 is nothing but the, after interchanging these rows into column, whatever I will get, that I will call it as delta 1. So let us consider here it is delta 1 be the determinant, delta 1 be the determinant determinant obtained by interchanging rows into column. After rows into column, it means I am changing these rows into column wise. So therefore delta 1 is equals to, so delta 1 is equals to, here it is, as earlier I wrote, the same thing I am writing here. So therefore here it is a11, a12, a13, a11, this row I am writing it as column, a11, a12, a13, again a21, a22, a23, next a31, a32, a33. First row I wrote here as the column, second row I wrote as the, here it is second column, third row I wrote here it is as the third column. Clear? So now I will solve this one. After solving this, if I get the same as whatever I got here the value, if I get the same value, then we can say that if I solve this determinant, the same answer I will get if I solve this determinant also. And this determinant is nothing but this is nothing but the interchanging the columns, rows into columns. Clear? So for that I will check one to check there whether after solving this whether I am getting the same answer or not. Now I will check. So again, so solve this one, and again first I will write here it is plus minus plus. My dear students, please remember you can take here it is, if for second row we will write it as minus plus minus, and here it is plus minus plus. This I am writing because to the every element we should multiply with minus 1 whole to the power subscript 1 plus 3 minus 1 to the power 1 plus 3, that like that we should write. So that I discussed already in the previous videos. So please refer there. Clear? And now what I will do, my dear students, I will take now column wise. Please remember in the matrix we used the elementary operations. In that case I told you that while solving the elementary row operations in the matrix, we can either apply the column operation or we can apply the row operation. But in this topic determinant, there is no rule. You can apply for the same question, you can apply column wise or row wise. So there is no condition that full entire question while solving in the matrix you should apply the same. Either you can apply entire up to completion of the question, you can apply row or column. But in determinants it's not the case. It is not the condition that you can apply. It is here you can apply row as well as once you can apply row and once you can apply column. That is, it depends on your situation of the given question. Clear? Here there is no necessary that up to completion of the question it's not necessary that whether we should apply row or column in that. But in case of the matrix, while solving the elementary operations, if you started with the row operation, you should end up with the row operation only. Clear? But in this case the situation is not like that. In this case there is no such conditions. Clear? So now my dear students, what I will do, I will solve by the column wise. That is first column I am going to solve. So here it is column, along the column. Now solving along first column. Solving along first column, this determinant. So if you solve this, I get here it is first column. So column wise, so here it is delta 1 is equals to, so here A11. So here there is no condition, you can apply column wise or you can apply row wise. Clear? So but I am solving here it is column wise. So if you solve by the column wise or row wise, you will get the same answer. But now I am solving column wise. So column wise is first plus A11 into, again So plus into A11. So I am not writing plus. So because it is understood, A11 again consider the determinant. So this element, that is where this A11 element is contained, that row and that column we should leave. Clear? So therefore I am leaving here this. So this column and this row I am leaving. Then the remaining elements determinant I will take A22, A32, A23, A33. Next, minus of this element, that is A21. Next, this element A21 where it contains that row and that column we should leave. The remaining elements is A12, A32, A13, A33. Next, plus this element A31. Again leave this row and this column. Take the determinant of remaining A12, A22, A13, A23. Clear? Yes. So now further simplify this, my dear students. So if you simplify this, we will get here it is delta 1 is equals to here A11 inside the bracket. Solve this one. How to solve? This element into this element minus of this element into this element. So now multiply this. So we will get A22 into A33. A22 into A33. Clear? And next, my dear students, minus of this element into this element. A23, A32. Clear? Next, minus of A21. Next here it is A12, A33 minus of A13, A32. Clear? And next, this I am here not sufficient space is there, so I will write here in this next step I am writing next line I am writing A31 into this element into this element A12, A23 minus of A13, A22. So now I will call it as 2. Clear? Now my dear students, please observe here this whether this 1 and 2 are same. Yes. See here A11 into A22, A33 minus of A32, A23, A23, A32. Clear? This is same. Next, minus of A12, minus of A, here it is, minus of, it's I think, it's, sorry, it's what I did, I took here this, again here, I took the row only, but here I am solving the along column wise. So therefore, I should take here this instead of A21, I should take it as A12. I should take this one because I am solving here along the column wise. So therefore, it's mistake here it is. I'll take here it is as I should take it as column wise, column 1. So therefore I am taking here this first column I am taking. So plus this is correct A11. So this row and this column I should leave and I should take the determinant. So A22, A32, A23, A33. Next this element minus of A12. Next determinant value minus of this element A12. Next leave this column and this row. This column and this row if you leave means the remaining elements are A21, A31, A23, A33. Clear? And next again here it is plus of A13, plus of A13. Again this A13 where it contains this row and this column we should leave. So if you leave this, remaining is A21, A31, A22, A32. Clear? A13, this column and this row I am leaving. A21, A31, A22, A32. Clear? Now simplify this further. So therefore, delta 1 is equals to A11 into this element into this element. So A22, A33 minus of A23, A32 minus A12 into A21, A33 minus A23, A31. Next plus of A13, A21, A31, A22, A32. Clear? Sorry, here I will simplify only. I will simplify this. So here, if you simplify this, A13 into here it is A21, A this element to this element A32 minus A22 into A31. So call this as 2. If you solve this as 2 means, so now I will check whether this 1 and this 2, whether these two are equal or not, that I am going to check. So here it is A11, A22, A33, A11, A22, A33 minus as it is A11 into A32 into A23. Here first there I will note A32, both are multiplication is there, so therefore it's equal. A32 and 23, A23 value is same as A32 and A23. Clear? Next minus A12 into A21 A33 minus A31 A23. Clear? And next here my students, A13 plus of A13 A21 A32 minus A31 A22. Clear? So therefore by observing this 1 and 2 from here, from 1 and 2, this delta value is equals to delta 1. Delta is equals to delta 1. So therefore we can conclude that is, if I have any determinant value, the value of the determinant, so the value of the determinants remains as it is if we change the rows into columns. Clear? So that the proof is in front of you. Please pause the video to note it down, or still if you have any doubts you can comment me, I will reply for that. And please remember my dear friends, once I told you that in the topic matrices, so transpose of a matrix. So what is transpose of a matrix? So I will give to you the transpose of a matrix is here. One note you can take here this. So note, what is that? If A is any square matrix, if A is any square matrix, then A transpose. What is A transpose? A transpose is nothing but, my dear students, A is the any square matrix. A transpose is nothing but interchanging the whatever elements in the matrix A we have. After interchanging these rows into column, whatever I will get, that matrix I am calling it as A transpose. Clear? Yes. The same thing I did here. This, if you consider this is the one square matrix, then delta 1 is nothing but this is nothing but the transpose of this. So therefore, what I am saying here is, the note is, if A is the any square matrix, then the A transpose, if I consider here, then if I take the determinant here, determinant of, this is notation will write like this, determinant of A is equals to determinant of A transpose. Can I write here? Because as I told here in this case only, so this is the one determinant, and I consider the delta 1. Delta 1 is nothing but the transpose of this only. So therefore, if A is the any matrix, any square matrix, then A transpose is, if A dash is the A transpose, then determinant of this is same as determinant of A transpose. Clear? So therefore, please remember this note. This will helpful while solving the questions. Clear? And next one, students, please another one case, another one note I am wanted to share with you. That is, it's not a note, but you can take it as some, remember some points. You can take it as some points. So what is that? If Ri is the ith row and Ci is the ith column. Now, if we interchange rows into column, in that case, we should denote it as Ci interchanging row I. Like this, we should write. Clear? In symbolically, if Ri is the ith row and Ci is the ith column, if we are interchanging, means the symbolically we should write it as Ci interchanging Ri. Like this symbol we should write. Ci interchanging Ri. Like this we should write. Clear. I hope you understood. Still, if you have any doubts, you can comment me. I'll reply for that. Clear. So my dear students, now we will solve some questions based on this. So now I am going to discuss the question. The next question I am going to discuss based on this property. Now my dear students, just I discussed the first property. I solve this question, or you can take it as the example for the verification of property 1. For this determinant, I will verify means I will check whether the given whatever we discussed that property is correct or not. That we will verify by using this example. Clear. So now what I will do, my students, first I will find the determinant value of this. So now I am expanding here, it is expanding along row 1. So I will find the determinant value of this, and that expansion is done along the row 1. So this is your row 1. Clear. So expanding along row 1. So therefore delta is equals to, and always I told you this is plus and this is plus minus plus. So expand this one. So here it is 2 into determinant of the remaining 2 cross 2 and order 2 we should converting here. It is clear. So this element, this row and this row, this column we should leave. We should take the element outside here. It is. So 2 into deleting this row and this column, remaining is 0, 4, 5 minus 7. Clear. Next minus of this element minus 3, and now again delete this row and this column, and here it is 6, 4, 1 minus 7. Next plus 5 into this row and this column. So next 6, 0, 1, 5. Please keep in mind, whenever you are watching the videos, you should be update the last videos, because in that last video only I discussed the how to find the determinant value. Clear. So please my dear students, if you watched my previous videos, then only you can understand, otherwise you may not understand the concept clearly. So please do watch my previous videos so that you can understand the present videos. Clear. So now I will solve this one, and here it is delta is equals to 2 into 0 into minus 1. This element, how to find the determinant of the order 2? We should multiply this element into this element, minus of this element into this element. 0 into minus 7 is 0, minus 5 4s are 20. Clear. Next minus plus 3, again 6, this element into this element, plus minus 42, 7 6 ja. Next minus of this element into this element, 4 1s are 4, but here it is minus of this, plus here it is 6 5s are 30, minus 1 into 0 is 0. Further simplify this. Further if you simplify this, this is 0 minus 20 is minus 20, plus 3 into minus 42 minus 4 is minus 46, plus 5 into 30 minus 0 is 30. Further simplify this. This is, here it is minus 40, 2 into 20, plus minus 2 to here it is 40, 2 into 20 is 40, plus minus, so here it is 46 into 3, so 46 into 3, how much it is? 3 6 is 18, 3 4 is 12, plus 13, plus here it is 138. Next plus 500, this is 150, 5 into 30. So further if you simplify this, you will get the delta value. So here it is minus 138 plus 150. So in 150, here it is 2, that is 12 I think. So that is minus 40 plus 12. 150 minus 138. So further if you simplify, delta is equals to minus, here it is minus 40 plus 12. You can solve. 40 minus 12. So 8, 28. Clear? So therefore minus 28 is your answer. Clear? And now my additions, what I'll do? I'll take, if this is all rough calculation. So clear? So little bit I am weak in tables, so therefore I solved here. But you should practice the tables. If you practice it up to 30th tables, it is very helpful and the calculations will be easier. While expansion in such cases, the calculations will be easier if you know the tables. Tables is nothing but, in Kannada we can call it as Maggigalu. Clear? So further what I will do, my students, this is the delta determinant value as it is. Now I will consider the determinant delta 1. Delta 1 is nothing but interchanging the rows into column. So now I will interchange rows into column. The first row I am writing it as first column. That is 2 minus 3, 5, 6, 0, 4, 1, 5, minus 7. So this is delta, whatever delta we have. To this I am interchanging rows into column. So after interchanging this first row 2 minus 3 5 column, second row 6 0 4 1 5 minus 7, I interchange the rows into column. Now if you solve this, again you will get the same value. That is what our meaning of the first property. Clear? Now I will solve again. Now expanding, I will expanding along column 1. Now I will expand along the column 1. Well, you can expand along the column 1, column 2, column 3, or row 1, row 2, row 3. Any whatever whichever is convenient to you, you can expand along that. Clear? There is no any restriction, because that also I discussed in the previous videos that for any value, for any determinant, if you can expand along row 1 or you can expand along row 3, row 2, whatever, the answer will always same as it is. Clear? Now I am expanding here this along C1. So further if expanding along C1 is, C1 means this is C1. So again first, whenever you are solving the determinant, first you should write the signs. Here it is, if you here it is plus minus plus, minus plus minus, plus minus plus. Like this you should take the symbol and then you should multiply with that. Clear? So here it is, I am expanding along column 1. So column 1 means first column I should take plus 2. Plus 2 into deleting this row and this column. 0, 5, 4, minus 7. Next I should take here it is this element. Minus of minus 3. Minus sign here is this minus into this element, that is minus 3. Again now this column and this row I should delete. So remaining elements are 6, 1, 4, minus 7. Clear? Next plus 5. Plus 5. Again this column and this row I should delete. 6, 1, 0, 5. So further simplify this, you will get same as it is, minus 28 only you should get. So therefore delta 1 is equals to 2 into 0 into minus 7 is 0, minus 20, minus minus plus 3, so minus 42, minus 4, plus 5 into 30, minus 0. Clear? So further simplify this, my students, you will get delta 1 is equals to 0 minus 20 is minus 20, minus 20 into 2 is minus 40. Clear? Plus minus 42 minus 4 is minus 46, minus 46 plus 3 is again here it is minus 138, because here the values here same it is minus plus 3 minus 42 minus 4 plus 5 into 30 minus 0. So therefore further if I simplify, here it is plus 150 and here delta 1 is equals to minus 28. The same values are there, so therefore directly I wrote the answer. So therefore you can check here this, you can write therefore delta is equals to delta 1. Clear? So please keep in mind, whenever we have the any square matrix, if we interchange rows into column, please remember You are not interchanging only first row or first column. You are interchanging entire rows into columns. So whatever rows are here, I interchange in terms of allowed in terms of the column wise. So for any square matrix, if you take the transpose of that means what? Whatever rows we have, that rows I am converting in terms of the column wise. So after converting that, the determinant value say will be remains as it is. For that, I solved here this example. Clear? So this is the one determinant I have. This is the after solving the determinant value, I am getting the same answer here minus 28 only after changing the rows into columns. Clear? So like this. So this is the first property. Please keep in mind, my dear students, these properties are very helpful while solving in the questions. Clear? And next, in the next video, I am going to discuss the second property, and that we will discuss in the next video. Please pause the video to note it down. Still, if you have any doubts, you can comment me. I will reply for that. Yes, we will continue in the next video. Thank you.